in the first part of the course, and then move to ES6 Plus, so ES6, ES7, and ES8 in the second part of the course. Okay? And so here's how that's gonna work. So we already talked about the JavaScript fundamentals using ES5, and we will continue using ES5 to look behind the scenes of JavaScript, do some DOM manipulations, learn all about objects and functions, and code up a huge real project. From there, we will then start using ES6 with an overview of what's new in the language. Then we're going to talk about asynchronous JavaScript, modern development setups, and code an even bigger and cooler real-world app, all using ES6, ES7, and ES8. Alright? Now, some people don't understand why I even bother showing you ES5 in this course at all, and actually have criticized me for doing so. And so here are a few reasons which I hope will make sense to you. So I truly believe that in 2018 and even 2019, it's still a good idea to learn the fundamentals of JavaScript in ES5 and then move to newer JavaScript versions from there, simply due to the fact that you will always have to understand ES5 in the future. And that is because many tutorials and example codes that you will find online are still written in ES5 today. Plus, as a developer, sometimes you will have to work on older code bases, which will most certainly be written in ES5 or even older. And all in all, I just believe that you will be a better developer if you start understanding how ES5 works and only then move up to ES6 or newer, because ES6 has some abstractions like classes that kind of hide how the language actually works behind the scenes. Alright, so I hope that this makes a lot of sense to you. And so let's now move on right to the next section. Hello, and welcome to the section about how JavaScript actually works behind the scenes. So now that you have a basic knowledge about the language, let's take your skills to the next level and take a look behind the scenes of JavaScript. And this is a part that many JavaScript courses out there simply skip or just mention very briefly. And that's actually really a problem, because this stuff is something that you really need to learn. Because if you truly understand how the language works, well, then you're going to be able to write better code, to debug your code, and to better understand other developers' code. And so in the end, everything that you're going to learn in this section will really make you a better JavaScript developer. Now, these lectures are a mix of theory lectures and coding examples. And so you'll actually immediately practice what you learn here. And if something feels a bit overwhelming, well, then don't worry, you can always rewatch a lecture or also come back to it later. So, are you ready? Then let's get started. So, in this first theoretical lecture, we will just very quickly see how the JavaScript code that we write is actually executed. So, JavaScript is always hosted in some environment, and that is most typically a browser, such as Google Chrome, Firefox, Safari, etc. And this is where JavaScript runs. There can also be other hosts, such as the Node.js web server, or even some applications that accept JavaScript code input. We will, however, always just focus on the browser in this course, which is exactly what we have been doing so far. So when we write our JavaScript code and actually want to run it, there's a lot of stuff happening behind the scenes. So what happens is that the host where JavaScript is hosted has some kind of JavaScript engine that takes our code and executes it. So in very simple terms, a JavaScript engine is a program that executes JavaScript code. There are many different engines out there, like Google's V8 engine that is used in Google Chrome, but there are others like Rhino, SpiderMonkey, JavaScript Core, and many more. Now, the first thing that happens inside the engine is that our code is parsed by a parser, which basically reads our code line by line and checks if the syntax of the code that we gave it is correct. So this means that the parser knows the JavaScript rules and how it has to be written in order to be correct, to be valid. And if we make some mistakes, it basically throws an error and stops the execution. If everything is correct though, then the parser produces a data structure known as the abstract syntax tree, which is then translated into machine code. So this code is no longer JavaScript code, but a code or let's say a set of instructions that can be executed directly by the computer's processor. And it's only when our code, already converted to machine code, actually runs and does its work. So it's not really important that you really memorize all of this. I just want you to get the basic idea of what actually happens once we choose to run our code. And there's actually way more going on behind the scenes, and different engines do things in a slightly different way. But this is absolutely enough for us to understand at this point. So let's now move on to the next lecture. The last lecture was a conceptual overview about what happens in the JavaScript engine once we run our code, how it's parsed and translated into machine code. Now let's focus on the order in which the code is run, and for that we need to talk about execution context. All JavaScript code needs to run in an environment, and these environments are called execution contexts. So you can imagine an execution context like a box or like a container, which stores variables and in which a piece of our code is evaluated and executed. We will go more in depth about this in the next slides. Now, the default execution context is always the global context. Remember that I said that an execution context is where a piece of code is executed. Well, in a global context, all the code that is not inside of any function is executed. And this is very important. So again, the global execution context is for variables and functions that are not inside of any function. Now, you can also think of an execution context as an object. Remember objects from the introductory lectures? So the global execution context is associated with the global object, which in case of the browser is the window object. So everything that we declare in the global context automatically gets attached to the window object in the browser. And it works like this. Declaring a variable called lastName or window.lastName is the exact same thing. It's like lastName is a property of the window object. And as we talked about in the intro lectures, properties are just variables attached to objects. So this makes sense, right? And I know this is a lot to absorb, so I really encourage you to take some notes about all these things to reference them later. And of course you can also watch these lectures again when you feel more confident with your coding. So remember, the global execution context is for code that is not inside of any function. But what about code that is in functions? It's actually very simple. Each time that we call a function, it gets its own brand new execution context. Let me show you that by an example. So this first declaration is not in any function. So we are in a global execution context here, as the red arrow down there shows on the right side. So this variable is stored in a global object. We will see how exactly that works in the next lecture. Next up, this function declaration is also in a global context. So we're still here in the same execution context. And the same about the second and the third function. And this is where the fun begins. Because here is where we call the very first function. And as I mentioned before, a new function gets its new execution context. And what happens is that this new context is put on top of the current context, forming the so-called execution stack. So for the duration of this first function call, the execution context for that function becomes the active context in which the code is executed. Okay, so let's get inside the first function with our arrow. So this a variable will now get stored in the execution context for this function, and not anymore in the global context. And now we call the second function, and I'm sure you can guess by now what will happen, right? So once again, a new execution context will be created and put on top of the execution stack. And here we go, this is now the active context. Okay, so now variable b is stored in this new execution context. And now we call the third function. And once more, a new execution context is created and put on top of the stack, as we already know. So now inside of the third function, we just have these two variable declaration and nothing more. So this function has now done all its work, and so we say that the function returns. So what happens to its execution context? It just gets removed from the top of the stack. Very simple. And then the context of the second function, which called the third function, is back to being the active context. And we go back to the second function. So this z variable gets stored in the currently active context, and after the function returns, the context is also pops off the stack. So back to the first function now, and here the same thing. The function is done, it returns, and so we exit it and the execution context pops off the stack. And like this, we executed all three functions, created three execution contexts, and popped them off the stack when the functions returned. I hope that all of that made sense to you. Now, you may ask, how are all these execution contexts actually created? And why is this so important? And the answer is in the next lecture. So go watch that one right now. Okay, so in the last lecture, we have seen when a new execution context is created. But what about how exactly that happens? So let's talk about that right now. Let's start by creating a representation of an execution context so that we can have a bit more detail about how it actually works. First off, as I mentioned in the previous lecture, we can associate an execution context with an object, which is what we have here. And this object has three properties. The variable object, which will contain function arguments, inner variable declarations, as well as function declarations. The scope chain, which contains the current variable objects, as well as the variable objects of all its parents. And the this variable, that we have already seen in action in the introductory lecture about objects. Alright, so how is this execution context actually created? Let's start with what we already know. When a function is called, a new execution context is put on top of the execution stack. And this happens in two phases: the creation phase and the execution phase. In the creation phase, we first have the creation of the variable object, and we will talk about that in the next slide. Then the creation of the scope chain, and this is a huge topic for itself, so we'll talk about that in the next lecture. And lastly, the this variable is determined in set. So basically, the properties of the execution context object that we have here on the left side are defined. Then in the execution phase, the code in the function that generated the current execution context is run line by line, and all the variables are defined. If it's a global context, then it's a global code that is executed. So let's now look at the creation of the variable object in the creation phase. So this is what happens in the creation of the variable object. The argument object is created, which contains all the arguments that were passed into the function. The code is scanned for function declarations, and for each function, a property is created in the variable object pointing to that function. This means that all the functions will be stored inside the variable object, even before the code starts executing. And this is very important for you to know. And lastly, the code is scanned for variable declarations, and for each variable, a property is created in the variable object and set to undefined. And these last 2 points is what we commonly call hoisting. Functions and variables are hoisted in JavaScript, which means that they are available before the execution phase actually starts. They are hoisted in a different way though. The difference between functions and variables is that functions are actually already defined before the execution phase starts, while variables are set up to undefined and will only be defined in the execution phase. As you remember from the last slide, the execution phase comes just after the creation phase. Now, hoisting is something that confuses many new JavaScript developers, so it's really important that you understand it right now. That's why we're going to write some code in the next lecture, so that we can see this in practice. So just to recap all of this once again, each execution context has an object which stores a lot of important data that the function will use while it's running. And this happens even before the code is executed. Alright, let's go to the next lecture to see hoisting in practice. So, hoisting may sound a bit confusing to you, but it's really not, believe me. So let me prove it to you by writing some code. So once again, I have some starter code for you, which I put here on my desktop. So let's just go to our text editor and open up the project. And in my case, it's brackets. And I have brackets and Google Chrome here side by side, such as we had before. So in case you're using brackets, just hit this button here and then hit open folder. And in my case, it's here on the desktop. So I'm just going to open this project, and here we are. So in this project, I have once again our simple HTML file, which is this bare construction of the HTML file, just the structure. And this time I already have included the script, which is also here already. And I have also already set the stage here for this lecture. Okay. So I'm just going to use some very simple functions here because I just want you to focus on how everything works and not exactly on what the code is doing. Alright, so let's start by writing a simple function, and we can actually use the one we have been using before, so the calculate age function. And remember, we have been writing it like this. Calculate age and then year. And this time we don't even want to return anything. I'm just gonna console log the result to the console. So 2016 minus the year. Very simple, but it's enough for us. So this is how we've been doing it up until this point. So we first declared the function and then called the function. So I'm going to use calculate age and let's say 1990, which used to be John's birth date. And now I'm going to open up our file, our HTML file, and here we go. And the console, so I told you in the last section that we can do inspect to open the console, but we can also come here to the View menu in Google Chrome, Developer, and then the JavaScript console, which is the same as hitting this shortcut, so Alt-Command-J on a Mac and probably Alt-Control-J on a PC. Alright, and here we already have the result. Okay, so this is the way we have been doing things. But with what we learned in the last lecture, we can also do it the other way around, right? Let me show it to you. I'm going to delete it and use the function here before I actually declare it. Let's see how this works out. Calculate age. And let's now put 1965, for example. And if I now reload this, then this still works. Okay. And this is what I've been telling you about in the last lecture. So this is hoisting. So in the creation phase of the execution context, which is in this case the global execution context, the function declaration calculate age is stored in the variable object, and even before the code is executed, right? And this is why when we then enter the execution phase, the calculate age function is already available for us to use it. So we don't have to first declare the function and then use it, but we can also first use it like this and only later in our code declare it. Now remember another thing that I said in the last lecture, which was that this only works for function declarations, but there's also something called function expressions, right? So let's see how this works out with function expressions. So let's write another function as a function expression. And this is how we do it. So we declare a variable, and now we're going to reuse the function that calculates the years that we have left until retirement based on the year of birth. So I'm going to call it simply retirement. And then function and the parameter year. Okay, we just want to console log here the result. And the way we have been doing this is to make 65 minus the age. So it would be 65 minus the age, and the age is just 2016 minus the year, right? Okay. And we need the parentheses here because we want this part to be calculated first, and only after that we want then 65 minus this part of the operation. And remember, if we group something together with parentheses, it gets the maximum precedence in the operation precedence table, right? So this is the absolute priority. Okay, so let's now use this first like this. So retirement 1990. And hit reload, and here we go. So for someone who was born in 1990, it has 39 years left for retirement, right? So now let's try and see what happens when we do it like this. So the way we have done it up here. So I'm gonna go ahead and delete this and try to first call the function and only after that to write it in the code. So retirement, and let's try again 1965, and then let's use it. Okay, and now this time it does not work. So this is what we expected, right? And once again, the reason for that is because this function is not a function declaration, but a function expression. And hoisting with functions only works for function declarations, which is what we have here, right? Okay, great. So in order to make this work again, I'm just going to commit out it here, but I will leave it in the code so that you can have it for yourself and download this code at the end. Okay, so that is function hoisting. Now remember that hoisting also happens with variables, but in a different way. So let's see some examples about that. So here we have functions, and take away this space here. So here, variables. So let's once again create a variable here. And I will create an age variable. So age, and set it simply to 23. And just to check that everything works, let's console log this variable just to see what happens. Okay, 23, exactly as expected. Now, what happens if we use this variable before we actually declare it in our code? So let's see what happens in this case. Console log age. So again, we're trying here to use this variable before we declare it in our code. So I'm sure you know by now what's going to happen. So here we go. All right. So we have undefined, and that's exactly how hoisting works with variables. Because remember, in the creation phase of the variable object, what happens is that the code is scanned for variable declarations, and the variables are then set to undefined. So imagine that we wouldn't even have this variable declaration here, if we then attempted to use the variable, we wouldn't get undefined, but we would get exactly an error, because then we wouldn't have any definition and JavaScript would not even know this variable. But in this case, JavaScript knows that there will be an age variable. We simply don't have the value yet. And that's also the reason why it's defined exactly as undefined, because in one of the first lectures we saw that variables that don't have a value yet will always have the data type undefined. Okay, so let's now take this one step further and write a small function called foo, which doesn't accept anything. All we're going to do here is to create our own age variable right inside this function. And let's set this one to 65, for example, and then console.log age in here, then call the function like this, and then console.log the age again. So what do you think is going to happen in this example? So let's find out. Okay, so these are the results of these two console logs here, right? So line 26 and 29, so 26 and 29. So why does this console log here print the age of 65, and then this console log here prints the age of 23? So it's actually pretty simple, and it's because this age variable here gets stored in the global execution context object, right? So in the variable object of the global execution context object. Sounds a bit confusing, right? But if you go through the last lectures again, then it will make a lot of sense. So again, this age variable is declared in this global execution context object. And then this foo function here gets its own execution context object, in which we can also store an age variable. And it can be the same name. It really doesn't matter, because these are two completely different variables. This variable age is defined in the variable object of the execution context object of the foo function, while this age variable is defined in the variable object of the global execution context object. So each one gets its own variable object. So we have two different variables, and so the results when we print them are different. And we can see that the hoisting works indeed also the same way. Console.log. So if we attempt to print the age before we declare it here, then we will have also undefined. So an undefined comes here from line 25, which is this. Okay, so I hope hoisting is a lot more clear to you now. And the most important use case for hoisting is not even variables, but it's the fact that we can use function declarations before we actually declare them in our code. And that's the biggest takeaway from hoisting, actually. So this is something very useful and something that confuses new JavaScript developers. So I hope that you understand it with these lectures. So you can take another look at the code or even rewatch some of the lectures that we've just seen. And then after that, once you're ready, then let's just move on to the next lecture. We talked about how execution contexts are created and how that is related to variable and function hoisting. That was the first step of the creation phase. So let's now talk about the second step, the creation of the scoping chain. So what does scoping even mean? Scoping basically answers the question, where can we access a certain variable or function? In JavaScript, each function creates a scope, which is a space or an environment in which the variables that it defines are accessible. In many other programming languages, a scope is also created by if blocks, for blocks, or while blocks, but not in JavaScript. So here in JavaScript, the only way that we have to create a new scope is to write a new function. And this is something very, very important in JavaScript. Also, in JavaScript we have lexical scoping. And lexical just means where something is written in the code. So it's about the position of something within our code. Lexical scoping means that a function that is lexically within another function, which means that it's written inside of another function, gets access to the scope of the outer function, also called the parent function. And with that, it also gets access to the variables and functions that the parent function defines. But let's look at an example to get a better idea of this. So here we have some more demo code. In blue, we have the global scope, which is the scope that is accessible from everywhere, from all functions. Like the global execution context, you can think of the global scope as the default scope. So in this scope, we have access to the variable a and also to the first function. In orange, we have the scope of the first function, which defines the variable b and the second function. And this is a local scope, not a global scope. And do you remember what I said about lexical scoping in the last slide? Thanks to lexical scope, this scope has also access to its parent scope and all the variables and function that it defines. And in this case, that's the global scope. And finally in green, the scope of the second function. In there we have a console.log statement which attempts to print the values of variables a, b, and c. Now, these variables are not defined in that function, only c. But as we already know, a scope has access to the scope of the function in which it sits lexically. So when running this code, the JavaScript engine will not find variable b in the current scope, right? So it just goes up and looks in the scope of its parent function and says, oh, here is b, so let's use that. And the same happens for variable a. It does not find it in the current scope, and also not in the parent scope, so it goes even more up, all the way to the global scope. And this is exactly called the scope chain. Only if the JavaScript engine does not find the variable anywhere, it throws an error and stops execution. Now, it's very important to note that this does not work backwards. For example, the global scope will never ever have access to the variables b or c, unless we return the values from the functions. So locally scoped variables are not visible to their parent scopes. And this is why I put that red arrow pointing upwards, because that's the only direction the scope chain works. Now, how does this actually work behind the scenes? Remember the execution context object that we have been talking about before? In the creation phase, each execution context object will get the exact scope chain, which is basically all the variable objects that an execution context has access to. Because remember, the variable object is what stores all the defined variables and functions. So in this example, in the second scope, we have access to the variable object of the second functions, of the first function, and the global variable object. So what do you think will happen with this code in practice? Let's go back to our text editor and find out. So I have this code already here in my starter code, which is the one that you will have available for download. So here's the exact same code that we had in the slide before. So how exactly do you think this is going to work? I'll give you a minute to think about it. Alright, so let's see the solution. Great, so the console log actually printed variable a, b, and c. So hey, hi, and hello, right? Hey, hi, and hello. So why does this work? So this works because, of course, the scoping chain. And in this case, thanks to the scoping chain, the second function has access to the variables of the first function and of the global scope. And that's because the second function is written inside of the first, which in turn is written inside of the global scope. And that's why we call it lexical scoping. So another extremely important concept and very much used in practice as well. Alright, so we have seen that the concepts of execution context, scope, and scope chain are very related. Now before moving on, I just want to make sure that you really understand how these are related and where the differences are. So we saw that the scope chain for each execution context is stored in the execution context object. But I just wanted to make very clear that the execution stack is different from the scope chain. So here we see another simple code example. And we already know how the execution stack works, right? So the first function gets called, which then calls the second function, which in turn calls the third function. And for each of these calls, a new execution context is put on top of the execution stack. Now, for the scope chain, things are a bit different. We see that the global scope contains the a variable, as well as the first and third functions. Then the scope of the first function contains the second function. And this is how I like to represent it. Now let's remember that the execution stack is the order in which functions are called, but the scope chain is the order in which functions are written in the code, where they are lexically in our code. So the order in which functions are called does not determine the scope of the variables within these functions. What determines the scope of variables is where the functions are written. Since the third function is not in the scope of the second function, of course it cannot access variables b and c defined in the second and first functions. It can only access the global variable a, because the function is written in a global scope. So, it's the execution contexts that store the scope chain of each function in the variable object, but they do not have an effect on the scope chain itself. This is important to understand. So what do you think will happen in this case? Let's go find out. Let's first analyze the code that we have here. So we have in a global scope the var a, which is defined as hello. We have the first function here, and we have the third function, all in the global scope, or in the global execution context. And then inside of the first function, we have the b variable, we have the second function call, and the function declaration. And we already know that because of hoisting, we can call the function before it's written here, right? Okay, and then in the third function, we just define variable d and attempt to console log variable c. Alright, so I'll give you a minute to think about what's going to happen once I hit the refresh button here in order to run this script. Okay, so I'm going to do it. I'm going to push the button. Alright, and so we have an error which tells us that C is not defined. So two things here. The first thing is, why can the second function even call the third function? So this bug here came from line 73, right? Which means that someone or somewhere this function was called, which of course was here. So the third function was called from the second function. And this once again is possible because of scoping. The second function has access to the third function because of the scope chain, right? So the second function has access to the global scope out here, in which the third function also sits lexically. And so the second function has the ability to call the third function because of the scope chain. And there's nothing new here, right? And now the second thing is, why do we actually get this error saying that C is not defined, even though it was the second function who called the third function? So the second function is the function that defined the C variable and then called the third function, but still the third function cannot access variable c, which it is trying to print here, which as we see resulted in this error. So by now I'm sure that it's obvious to you that the third function cannot access variable c because the execution stack is different from the scope chain. And so to answer the question, who can access the c variable, the order in which the functions were called does not matter. All that matters is that the third function is in a different scope than the second function, and so it cannot access variable c. So which variables could the third function actually access? So try to figure that out by yourself. So did you get it? Okay, so it's variable a and d. So let's just test that. So I'm going to console log this one here and then do console.log a plus d. And if I run this now, then I have hello John. And hello is a and John is d. So these are the only variables that we have access to because they are in a scope chain for the third function. Great. This is really cool, right? You are already familiar with a lot of super important and advanced JavaScript concepts here and a lot of important theory. And I can absolutely guarantee you that you already know a lot more than a lot of JavaScript beginners. So this is amazing, right? There's only one thing that we have left in this section, and that is the this keyword. So let's go right to the next lecture where we are going to talk about that. See you there. So we have seen in this section that the creation phase of an execution context has two steps: creation phase and execution phase. So far, we have talked about the object variable creation as well as the scope chain creation, both part of the creation phase. I hope that you have followed along just fine and taken a lot of notes, so that we can now talk about the third and last step of the creation phase, which is determining and setting the value of the this variable or the this keyword. So the this variable is a variable that each and every execution context gets, and as we already know, it is stored in the execution context object. So where does the this variable or the this keyword point? In a regular function call, the this keyword simply points at the global object, which in case of the browser is the window object. And this is actually the default. Simple as that. In a method call, which as you remember is a function that is attached to an object, the this variable points to the object that is calling the method. And something very important about this is that the this keyword is not assigned a value until the function where it is defined is actually called. So again, even though it appears that the this variable refers to the object where it is defined, the this variable is technically only assigned a value as soon as an object calls a method. But armed with all the knowledge that you have gained in this section so far, this makes total sense, right? And that's because we know that the this keyword is attached to an execution context, which is only created as soon as a function is invoked, which also means called. So invoked and called are the same thing. Alright, so let's now check out some practical examples of this in the next lecture. After the theory about this keyword, now comes the practice. So let's start and simply log the this keyword for this global execution context. So all we have to do is console.log this. And what can we expect here? Alright. So all this means is that the this keyword in the global execution context is very simply the window object. And that makes sense, right? That's because the window object is the default object, as we learned in the last lecture. Okay, let's comment out this part of the code and let's write a simple function. And once again, we're going back to our calculate age function because we already know that so well. All right, so console.log 2016 minus the year. And what we also want here is to console log the this keyword once again. This. All right, and when we call this function, what can we expect this time? Actually, we have to write the function call up here. So calculate age, I'm going to go with 1985. So let's refresh this and try to guess what we're going to see now. So we first have the result of 31, which comes from this log here, and then the this variable is once again the window object. So does this make any sense to you? I hope so, because this is a regular function call and not a method. As we learned in the last lecture, in a regular function call, the this keyword always points to the window object. And it actually makes sense, because the object that this function is attached to is the global object. And it actually makes sense, because the object that this function is attached to is the global object. So it has to be the this variable here as well. Okay, so not a method, a regular function call. So the this variable is the global object. So let's move on to an object here. And we'll go back to our old John object. So name, John. And here's not a semicolon, but the normal comma. Then year of birth is 1990. And let's now add a method here, and it will be our calculate age method once again. So calculate age, and once again this is a little bit different than what we had before, right? Because this is like a function expression and not a function declaration. So in here we can also console log this keyword. But first of all, we have to perform the method call. And that's as simple as this. So we use John and then we use to calculate age method on it. So what's going to happen now? And let me actually comment out this part of the code. All right. So the this variable now is the John object, and it makes absolute sense, right? Because as we know, the this keyword refers to the object that called the method. And in this case, it was the John object. So of course, it has to be the this variable. And we actually already saw this in action before in the introductory lecture about objects, but at the time we didn't really understand it, but now it makes total sense why the this keyword refers to the John object, right? And now it also makes sense why we can then use this to calculate John's age. So console log this dot year of birth, right? So let's run this again, sorry. And then we have final result. No, of course not, because it's of course 2016 minus this. All right, here we go. Now let's take this even a bit further here. And what we're going to do is to add a function inside of the calculate age function or method. So I'm simply going to call it inner function, okay? So this function will not really do anything. I just want to console log the this keyword in here as well. All right, and then we can call it, of course, inner function, and just like this, because it doesn't have any parameters. So now when we call the calculate age method down here, not only will these two console logs here happen, right? But also this function will be declared and then called, and therefore the this keyword will be logged as well. And now try to guess what the this keyword is going to be like. All right. So once again, the this keyword in here is the John object as expected. Then the outcome is of course 26 as we had before. But now comes something that looks rather strange, right? And that's the fact that the this keyword in this inner function here is now back to being the window. And this is a bit counterintuitive, right? And in fact, some people in the JavaScript community agree with this and others don't agree. Some people think that the this keyword in here should still be the object, this is the John object, right? But to me, actually, it makes sense that it's not, because it's simply the rule. And the rule is that when a regular function call happens, then the default object is the window object. At least that's how it happens in the browser. So once again, this is not a method, because the method is calculate age, so it's a method of the John object. But this function here, although it's written inside of a method, it's still a regular function. So when we call it, the this keyword will no longer point to the John object, but instead point to the window object. Okay, and this is something very important to keep in mind for the future and also for a future project. And now that this is really crystal clear, let's now complicate things a little bit more. So remember how I said that the this variable is only assigned a value as soon as an object calls a method? So I said this was important, so let's now see an example. And for that, I'm going to create another object, which will be called Mike. Var Mike will be another object, and this name will now be Mike, of course, the year of birth can be something like 1984. All right. Now imagine that we want to calculate the age of Mike. So one thing that we could do is of course to go ahead and copy this calculate method here and paste it here in the Mike object. But we could be really smart and instead do something that's actually a very common practice in JavaScript and that we will also use more in the future, and that's something called method borrowing. So we are going to borrow John's method to use it on Mike. And how are we going to do it? It's very simple. We just say that we want Mike.calculateAge to be John.calculateAge. Simple, right? So you see that in this case we don't have the parentheses, because these parentheses are for calling a function. And now we simply treat the function here as a variable. And so we can say that we want the Mike.calculateAge function to be the exact same as John.calculateAge function, which is this one here, right? Alright, so if we now go ahead and use a function calculateAge, because now I want to really call it, so I use the parentheses. So now I'm going to go ahead and call the function. But first I will actually make it a bit simpler. So I don't want this code here anymore to get in my way. So I'm now going to call it, and what are we going to see? Alright, so from the John calculate age call here comes the John object and the 26 age of John. So exactly what we had before. But when we now call the calculate age method for Mike, which we had borrowed, then the object becomes the Mike object, and now we have Mike's age here. So this is truly amazing, right? And this proves what I had said in the beginning, which is that the this variable is only assigned a value when the object calls the method. So if it wouldn't be like this, then this variable here would always be John, right? Because it's in fact attached to the John object. But when we now call the same method from the mic object, then the this variable becomes the mic object. So again, the this keyword only becomes something as soon as the method gets called. And this is something really important once again. Okay, so I hope that this is really crystal clear now. And with this, we reach the end of our theoretical lectures. And for me, it's really good to see that you're still with me after all of these more theoretical lectures. And believe me that these lectures were really worth it, and they will absolutely make you a better developer over time. And even if you don't understand it now, I'm sure that you will eventually. And so from now on, we can build on what we've learned so far, and we can now focus even more on coding. So let's continue doing that right now. See you in the next lecture. This section is about DOM manipulation with JavaScript. So up until this point, we have only talked about the language itself, but never about how we can actually use JavaScript in the browser to make it interact with a web page. And that's why in this section, we're going to build our very first small project together. And this project is a very simple but fun game that we can play in our browser. So it's basically just an HTML web page that is going to interact with the JavaScript code that we'll be writing. So you will learn a ton of new stuff, and of course you will also use some of the concepts that you've learned so far. So let's go have some fun with this project now. So in this section, we are going to make JavaScript interact with a web page for the first time. And the technical term for that is doing DOM manipulation. So in order to do that, we need to first know what the DOM and DOM manipulation actually is. So DOM stands for Document Object Model. Now, the DOM is a structured representation of an HTML document that can be used to connect web pages to scripts or programming languages such as JavaScript. Imagine a very simple web page like the one we see here on the right side. We can say that each HTML element can be represented by a box like this, right? Now, the DOM is a fully object-oriented representation. So for each of these boxes, there is an object in the DOM that we can access and interact with, right from our JavaScript code. But before moving on, I just want to make crystal clear that JavaScript and the DOM are two different things. So what we have been doing so far was to just use the JavaScript language without any interaction with any web page. All we did was just to print some stuff to the console. But now we're going to use special JavaScript methods that allow us to interact and manipulate, which means change, the DOM and therefore the web page. And since I said methods, that means that they are functions attached to some object, right? And that object is the document object. So this is the object that gives us access to the DOM. Okay, once again, the HTML web page content is stored in the DOM, which can then be accessed and manipulated via JavaScript. And that is exactly what we're going to do in the project in this section. In case that you have no idea what HTML and CSS are, you're in the right place. Because in this lecture, I'm going to very quickly go over the most important parts of HTML and CSS, just by looking at the project that we will be working on in this section. So if you're already familiar with HTML and CSS, then please feel free to mark this lecture as completed and then move on straight to the next one. This is the starter code of the project that we will be working on in this section. And this here is the HTML document. Alright, so an HTML document is what always holds the content of our web pages. In HTML, we have elements which are composed of ending tags, content, and closing tags in most of the cases. We then write these elements into one another and like this create a nested structure. And there are different elements for different things, such as links, paragraphs, images, sections, etc. For example, the div tag here has this opening tag, this closing tag, and this content here in between. And in this case, the content itself are even more HTML elements. But eventually some of these elements have some plain text content here. For example, here, or here, or here. Okay, so HTML elements can also have attributes, which are these. So this is the class attribute, the ID attribute, or for example, the source or alt attributes. And there are a lot of different attributes. Now, probably the most used one is actually the class attribute, which is this one here. And it allows us to give a certain element a name. And IDs, which we have, for example, here, also allow us to give elements a name. But the difference is that an ID has to be unique, but a class name can be used over and over again throughout the pages. For example, we have player name here and then down here again, but we have, for example, the ID name 0 only here because down here it's called name 1. Alright, so these are elements and attributes. Now about the structure of an HTML document, it is always divided into two parts, which are the header and the body. So the body is what we just looked at, and it contains the visible content of a web page. So it's basically everything that's here enclosed into these body tags. So that's it for the body. Now the header is what contains additional information about a web page, such as the title here or even some page keywords. And we can also do other things here. For example, in here we import into our code a custom font from Google Fonts and also an icon font, which will give us some nice icons that we can use to make our interface look nicer. And then here in the next line, but also still in the head of the HTML document, we connect our HTML file to a CSS style sheet, which brings me to CSS. So let us open our external CSS file, which is this one here. Okay, so if HTML is the content of the web page, then CSS is the presentation. And here in the CSS, we simply write rules to style our web page. So we have all these rules here. So here and all the way. So all this file is filled with CSS rules. And the way we connect the HTML with the CSS is by using usually class names. We can also use IDs or other selectors, but the most common one is the class selector. So this is the class name that we specify in the HTML. So let's go look at that. So player name, and that is right here. So the rule that we just saw here in the CSS styles all the elements which have the class of player name. And this here is the class selector. And if we go up here, we see another selector, which, for example, we have this one here. And this is called a type selector because it selects all elements with the type of body. So it simply selects the body of our web page. And we also have the universal selector, which simply selects all of the elements on the web page and applies these styles to all of them. Okay, so I think that is actually all I had to tell you. I hope that you got a small idea about HTML and CSS now. This should absolutely be enough to allow you to follow the next lectures, where we are going to need some of these concepts. If you want a full deep dive training into HTML and CSS, then you can of course try out my other course, which is called Build Responsive Real-World Websites with HTML5 and CSS3. Let's finally set up our project and take a look at the game that we will code, as well as the rules of that game that we will need to implement in order to make it work. So I have the starter code here on my desktop once again. So this code here that is available for download. So I'm gonna go to my text editor now and open up that project. And by now you already know how it works, right? So I go to my desktop and then hit open. And this text editor, so brackets, creates a new working project for me. Okay, so this time the starter project includes a little bit more than just a bare bones HTML structure. So this time we have a real user interface that I coded for this game here in HTML, as well as the CSS code for this project. And you can of course take a deep look at it if you want to know exactly how I coded that up. But on this project I want to focus fully on JavaScript and not how the HTML and CSS works in the background. Okay, so let's now take a look at the interface that I coded for this. And now as you see, I have the text editor here in full screen because now I need all the screen size that I can get. And I have the interface here on this side. So this is a beautiful interface that I created for our small little game, which is this one. So we have two players on left side and right side. And the goal of the game is to get to 100 points first. So I want to actually first take a look at the rules with you before I show it to you in action. So let's go back and open our JavaScript file, which is this one. And once again, I already connected it for you. So down here we have the script where we include the app.js file. Okay, so this is the file which is empty, except this comment here, which includes the game rules. So as I mentioned, there are two players and the game is played in rounds. And in each turn, a player rolls a dice as many times as he wishes, and each result gets added to his round score. But if the player rolls a 1, then all his round score gets lost, and after that, then it's the next player's turn. But in order to avoid that, the player can choose to hold, which means that his round score gets added to his global score. And after that, it's again the next player's turn. And the first player to then reach 100 points on the global score wins the game. So let's now see the game in action very quickly. So player 1 starts the game and I'm going to start roll the dice. Alright, so I rolled a 4. So down here on my round score, I now have a 4. And I'm going to choose to hold, and then the 4 points get transferred to my global score, which we have up here in this big size. And now it's placed to turn, which we can see by this gray background and here this red dot. And I'm going to roll a dice as well, and now I have 5. And I'm going to choose to roll again, and I rolled a 3. So 3 plus the 5 that I had before is now 8. And I'm going to choose hold as well. So now player 2 here is in the lead. Alright, player 1 once again. Now I'm going to roll the dice all the way until I roll a 1, which as you know will make me lose all of the score. So just to show you what happens. Alright, so I apparently rolled a 1 and lost all of my round score and nothing got added here, right? So I will now play with this one here, choose hold, and let's play this game until the end. And we have a winner here. Player 1 won the game. Alright, so this is how this game works. Super fun, right? I think it's really cool for a first real project. So let's go straight to the next lecture and start coding this. Now it's time to finally start coding up our game and put into practice what we learned so far about the DOM. But one more thing before that. From now on, in all the coding lectures of a project where we learn multiple new things and concepts in one single lecture, I will give you a quick summary like this one, so that you can later reference what we did in each lecture. And this will be very useful in case that you need to ever come back to these lectures later. And that being said, In this lecture we are going to learn how to create our fundamental game variables, how to generate a random number, how to manipulate the DOM, and how to read from the DOM. So here we are back in our JavaScript file. Let's create some empty space here. Okay. So one thing that I didn't mention yet so far is that this game is actually called the pig game. So if you try to Google this, you will then also find these exact same rules and also some variations that we'll maybe talk about later. Okay, but let's start. So we need to first create a couple of variables to keep track of the most important things happening in our game. And probably the most important thing of all is the score for each player. Now I could go ahead and create a variable for each player like this, score1, set it to 0 and score2 and set it to 0 as well. But we want to keep things clean, and so I only want one variable. So how are we going to do this? We are going to use an array. So I'm just going to call this one scores and set both scores to 0 in the beginning, right? Okay, and I also want a variable for the round score. And this only needs to be one value because we only have one score at a time, one round score at a time, right? So round score equals 0. Now let's keep our code a little bit more organized. So instead of doing it this way, I'm actually going to declare all of these variables up here like this. So var scores and round scores, and then remove the var from here. Okay, just like this. So these are the variables for the scores. What I also need is a variable which will tell me which is the current active player, right? And this variable is to keep track of the player that is currently playing. So let me declare it here actually. So active player, and then I will set it to 0. So 0 will be the first player and 1 will be the second player. And I'm doing it this way because later we will use this variable to read the scores out of this array. And since this array is 0 based, we need the 0 for the first element here and then the 1 to read or write the second element. Okay, so these are the basic variables that we need for now. We will probably add some later, but it's enough for now. So let's now think about the dice. So in order to create the dice, we need to calculate a random number, right? So let's call it dice. And of course, as you know, I need to declare it here. So dice. And now I'm going to use the math object. And the math object is a JavaScript built-in object that has a lot of properties and methods for mathematical constants and functions that can be very useful for us to do this kind of calculations. And the random one is one of them. But let me actually show it to you in the console. So I'm just going to set this to some value and then come back later here. So to open the console, I'm opening Google Chrome, and actually I will simply open my file here. So the index.html file, which will then open our app and our user interface. Okay, so here we have it. So this is the default. So when we open this, we actually already have some pre-filled numbers here, as we can see in our HTML here. So you see here 43 is the score for player 0 and 72 is the score for player 1. Okay, but back to the console. I'll hit inspect and then head over to the console. Now let's start by using the math object. So math dot, and now there's a very handy method called random, which basically gives me a random number between 0 and 1. So if I run this again, it will give me another number, and another, and another, and another. So these are all different, right? Now I don't want a number between 0 and 1, right? I want a number between 1 and 6. So the first thing I'm going to do is to multiply this value by 6. So let's clear the console. So if I multiply this by 6, then we will have a number between 0 and 5, right? So 0.9, 4.6. Okay, but you see the problem here, because these are decimals. But we don't want decimals, what we want is an integer, right? So there's another very handy function in the math object, which is called floor. And the floor method simply removes the decimal part of a number. So let's test it. For example, 4.6 will become 4. Okay, so what we should do now is to use this with the math random times 6, right? So I'm going to use math.floor of math.random times 6, which is what we had before. And now this will give me a random number between 0 and 5. So 0, 3, 1, 2, 2, 1, 4, 4, 3. Okay, so as I said, this will be a number between 0 and 5, but we want from 1 to 6, right? So all we need to do now to make this perfect is to simply add 1. Okay, so now this will give me a nice number between 1 and 6. So let's now copy this, and I did this in the console so I could show you the effects of the random number generator. But now we want this in our code. So I'm coming back here and paste it here. So now our dice variable takes this random number each time that it's defined. So let's now console log this dice. Can close up the console. No, actually we can't, of course. Alright, so 6. And if we now reload this, then this time we have 5, 3, 6. So as you see, this is a random number now. Okay, so this was the first thing. Now the next thing is to actually do some DOM manipulation. So let's do that. So as I said in the theoretical lecture, the object that will give us access to the DOM is the document object, right? So let's use that. Document. Now there are a couple of methods that we can use to select elements from our web page. And the most useful one, and the one that I use all the time, is query selector. So again, I need to use the dot and then query selector. Alright, and how does query selector work? So query selector is really to use because it lets us select stuff exactly the way we do it in CSS. The only difference is that it only selects the first element that it finds, but there's a solution for that I will show you later. But for now, what you need to know is that it's really easy to select things with query selector, because if we know how to select stuff in CSS, then we can do it with query selector. So let's now select something from our page. And what I want to do is to select this text here and put the value of our dice right here, so that we don't have to open up the console anymore to see our value, but instead we can print it right here. So in our HTML, we see that this 43 is right here. So in order to select this, we need to use this ID score 0. And if we wanted to do the same thing for the other player, which is player 1, then we'd have to use score 1. But now all we need is score 0 here. So we need a string here, and then, as you know from CSS, in order to select IDs, we use the hash symbol and then simply score 0. And that's it. So now we have selected the element. Now if we want to change the text in this element, then we need another method, which is the text content method. So text content. And now we can simply say that this should be the dice, which is the variable that we define up here. So I can now remove this and check out our web page. So let's now really close the console and reload this. And now actually the dice appeared here, not where I wanted it, not down here. So let's reload this. Okay, so the value appears here, but it's no problem, right? So 6, 6, and 6 again, and now 2, and 5. All right, so this is actually working, not the way we intended to, but it's still working, because we actually had to select current 0, not score 0, because score is the global score and not the round score. So let's put it in the current. Great. Now right in the beginning we defined a variable called active player, right? So this was to keep track of the player that is currently playing, and we're going to use this variable to read and store values here, but also this number here is used in our HTML. For example here, for player 0, for score 0, and current 0. And down here we have 1, 1, 1. So we can also use the current player variable to select stuff, right? All we need to do is to build our string here. So I can do current and then plus active player, right? Because of type coercion, JavaScript will then convert all of this to current 0 if this is 0. But if it's 1, then it will be current 1, which is exactly what we had before. But now it's more dynamic because then we only have to write it once. So when we change the active player, then the score will be printed in the other label. So let's test this. So let's set this to 1 and let's see how this works. Okay, so now we have it here. Let's dice again, roll the dice again. So 6, 1, and 2, and so on. Okay, cool. So what we did was to simply change the content of an HTML element here. Now to change the content of a selection, there are actually two ways. So we used the first one here, which is text content, but there are two ways. And the text content that we have here can only set plain text, so no HTML. But if we want to put some HTML also in the selected element, then we have to use the inner HTML method instead of the text content. So let's see how that could work. So let me comment this out and write it again. So document.querySelector, and I want again the current one. What I'm going to do is like this, active player. And now instead of text content, I'm going to use inner HTML. And now I will write some HTML, which of course needs to be a string once again. Because if I would just write it like this without being a string, then the JavaScript parser would think that this is some JavaScript code, which of course, if we have something like this, then this is of course not JavaScript, and we would have an error. So every time we want to write some HTML here in our code, it needs to be a string. So let's now use the EM element here around the dice value, which will then emphasize it. So basically it will be an italic text. So dice, and then close this element. So let's see what happens now. Alright, so now we have this italic text here. So it is slightly to the side, right? This number 4. 4, 6, and so on, so on. Okay, so what would happen if we would simply do this with the text content method that we used before? Text content. So let's reload this once again. And then we would have all this text here, because once again with this method we can only set text and not HTML. So then it would interpret all of this HTML code as plain text. So this is not what we want. So this was just to illustrate you. Set it back to inner HTML, and I will comment it here, because what we want really is this. Okay, so we just did our very first DOM manipulation, which means that we use this query selector method here to manipulate, to change values in elements of our web page. Now we can also use this method to actually only read the elements from our web page and then store them in some variable, for example. So let's now do that. I will create some space. So let's simply create like a random variable, and this is just to show you var x, and once again document.querySelector And let's now use something else. For example, the global score here, right? Which is 43. So again, this is an ID. So I use the ID selector that we already know from CSS, and then score 1. And this time I'm just going to write it out like this, or actually score 0, because this is just to show you how we could use a query selector the other way. Okay, and now the text content. So this time we don't set it to equal anything, because again, this is just to read the value or the content of the element with this ID, score 0, and then store it here into variable x. So let's quickly console.log x so that we can see that this also works this way around. So I am going to hit Command-Alt-I to bring up the console, and let's now reload the page. And here we are. So 43, which is the value that we read from here, stored in our x variable and then printed right here to the console. So this works not only for setting, but also for reading. And in this case, when we do it like this, we say that it's a setter because we set a value, and in this case, we say it's a getter because we get a value. Alright, and now there's only one more thing that I want to show you in this lecture, which is that we can also use the query selector to change the CSS of some element. So let's now use the document object once again, query selector, which will return a selection, and I'm going to go back to the web page. What we want to do now is to hide this dice here right in the beginning. So when we open up the game, we don't want to see this dice with this random number here, right? So in CSS, we do that by setting the display property to none, right? So let's do that. So in our HTML, where do we have the dice? And it's right here. So it's this image here with the dice class. So this time we have not an ID, but a class. And to select the class, it is the dot selector. So all we need to do is dot dice. Alright, so this gives us our selection. And now instead of changing or getting the content, we want to change the style. So we first need to use the style method and then the CSS property that we want to change. And it's as simple as that. So as I said, we want to change the display property and set it to none. So we write display and then set it to none. And that's really it. So if you remember what CSS looks like, let's take a look. So this here is the property and this is the value. And in JavaScript what we do is we use first the style method, and then this is the CSS property and this is the CSS value that we attribute to this property. So let's see if this actually works by reloading this. And yeah, here we go. So our dice is now gone. If we now inspect this page, let's actually do this and go here to our dice, then we can see that with JavaScript what we did was to basically change the inline CSS and set the display to none here. So we also can see it in our HTML. So we now have the style attribute here and the display was set to none. Okay, and that's it for this lecture. Now the next step would be to actually display the value each time that we click our nice button here, right? Because right now nothing really happens, but what we want is to show our dice here and to show our score, and right now nothing of that happens. So let's do that in the next lecture. Before we move on with coding the roll the dice button, let's talk about another important topic that is closely related with the DOM and DOM manipulation, and that's events. Events are like notifications that are sent to notify our code that something happened on the web page. And events are triggered by things like clicking a button, resizing a window, scrolling down, or even pressing a key. We can use event listeners to code responses to all these events, like opening a pop-up window, showing animations, and so on and so forth. So an event listener is just a function that basically sits there and waits for a specific event to happen. And how is that event then processed? Well, first we need to remember about the execution stack. And that's because the rule is that an event can only be processed or handled as soon as the execution stack is empty, which means that all the functions have returned. So in here, we currently have 2 execution contexts on the stack. So these have to return first. Just like this. Okay, so besides the execution stack, we also have something called the message queue in the JavaScript engine. This is where all the events that happen in the browser are put, and they sit there waiting to be processed, which, as I said, only happens once the execution stack is empty. And that is the case now, here in our example. So the next event in the line will now get processed. Remember from the last slide that we can have something called an event listener, which is a function that reacts to an event. So that event listener is now called. And since it's a function, it gets its own execution context, which is then put on top of the stack and becomes the active execution context. So this is how events are processed and how event listeners work. So let's now use what we just learned in practice in the rest of the lecture. In this lecture, you will learn how to set up an event handler, what a callback function is, and also what an anonymous function is. You will also learn another way to select elements by IDs and how to change the image in the HTML image element. Alright, so let's now set up our event handler. And the first step is to select the element in which the event will happen. So in this case, it will be the button where we will roll the dice. So this button here, right? So let's go into our HTML file and find out how this one is called. And it's this one here, so roll dice, and the class for this one is the button roll button, right? So btn roll. Okay. Once again, we need to select this element. So by now you've seen that it always works like this. So we first select something using query selector, so like this, and then after that we do something with that selection that the query selector method returns. So once again, we use the document.query selector, and now we use the button roll. Alright, so we have our selection, and now we can add the event listener, which is as simple as this, add, and here we already have it, so add event listener. And here we have 2 arguments. The first one is the event type, which in our case is simply click. So there are a lot of events, as I told you, and this one is the click event, but there are a lot of them. And so we have a nice handy reference, which I already have here. So once again, this is on the MDN webpage, where I also showed you the operator precedence table. So let's search for the one that we use. So click. So this is the click event. And it's one of the mouse events, but there are lots of them. So mouse enter, mouse move, mouse over, mouse down, mouse up, and all of these events. Then we have drag and drop events. We have these media events. And we also have keyword events up here, clipboard events. So when we copy or cut something. And as you see, lots of events are possible. For example, when the page unloads or when our page loads, and all these kinds of events. So when you need something else, beside click or beside anything that we will learn in this course, you can just come to this reference here and use it from there. Okay, so the first argument to the add event listener is the type of event. Now the second part is the function that will be called as soon as the event happens. So for now I will leave this empty. So imagine that we would have a function that we want to call when we click on the button. So I'm just going to call it function button. Comes something and just like this. Do something here. Okay. So remember, if we wanted to call this function, we would do it like this, button and then the call function operator, which is this one, right? So in order to call a function, we always use these parentheses. Now, if we want to use this function as our function that is called here, as soon as we click on the button, then we would simply do it like this, just the name of the function without the parenthesis operator, because we don't want to call it right here. We want the event listener to call the function for us. And this button function is then called the callback function. And that's because it's a function that is not called by us, but by another function. So this is what a callback function is, a function that we pass into another function as an argument, and this function, in this case the event listener method, will then call that function for us. Alright, but what if we didn't want to have an external function that gets called by the event listener? We could simply add the function right here. So instead of having this function name here, we could write our function right here. And that would be an anonymous function. So another concept here. So an anonymous function is simply a function that doesn't have a name, so it cannot be reused. We can just write function here, like this, then the usual way with our curly brackets, open it, and then write our function code right here, such as we did before. So once again, we can write, do something here. Again, if we don't want this function here on the outside, we can very simple write our function right here into this event listener method. And we do that by writing an anonymous function, which is a function that doesn't have a name and that we therefore cannot use outside of this context here. So we cannot call this function button to use it then later in another place. So this function can then only be used here. But in this case, that's what we want, because we don't want to use the button function anywhere else. All we need this to happen is when someone clicks on the button. So an anonymous function is the perfect solution here in this case. And this is usually the way that we handle this. Now, what happens as soon as someone clicks the button? So let's use comments here to define our next steps that we have to take here. So first, we need a random number. Right, and we already did that. So let's already copy this here into our function. So we only need this number as soon as someone hits the button, right? We don't need this right after our application loads. We only need this as soon as someone clicks. Okay, and after that, what we need then is to display the result, right? And after that, what we want to do then is to update the round score, but only if the rolled number was not a 1. Because remember, if we roll a 1, then we lose our current score and it's the next player's turn. Alright, so here our dice variable, I will actually only declare the variable here in this function because I don't need it from the outside. So remember, due to the scoping chain, here in the outside scope, we will only have access to the variables that are in the scope and not access to the variables that are in the scope of another function. So I will remove it from here. And now this function is the only one that has access to the dice variable. But the other way around, from this function here, we have access to the outer scope, right? So in this function, we will have access to the scores, the round score, and active player variables. And this is very important. So once again, the scoping chain is something very important, and really important also to understand. Okay, so we have our random number. Now we also need to display the correct dice number, right? So we first have to make it visible again because we hid it up here. So we set the display style to none. So the first thing is to bring the style back to block. So in CSS, when we want to display something as a block, we simply use the display property and set it to block. So document.query selector, and we see from up there that it's just the class dice. And then .style and .display and set it to block. Alright, but we also need to set the correct number, right? And this is why these images, so 1, 2, 3, 4, 5, 6, have the number here in their name. So this is a trick that I used so that now it's very simple for us to display the correct name. All we need is to write this name and then add the number of the dice value that was rolled, right? So if we roll a 1, then we need the dice 1 image. And the same thing for the other numbers. So how do we do that? Once again, we will select our dice, but instead of always doing the same selection over and over again, which is a process that takes up some time, so it's not perfect if we do all the same operation all the time. So what I can do instead is to create a variable where I store the selection and then use this variable whenever I need it. So I will create a new variable, and once again, we only need it in this scope and not in the outside. So I only declare it here in this function. And I will call it dice DOM, simply because it's the DOM object for this dice. And so now I'm going to copy this part because this is effectively our selection, right? So query selector of the dice is what we select. And now all we have to do is to use the variable that we just created. So we can make it like this. And now down here we can use it again. And we don't have to make the selection over and over again. Now, how do we change the image of an image element? So we see here that the image is an img element and the source is what defines which image is displayed. So it's very simple to change this source attribute, because in JavaScript all we have to do is exactly that, source, src. And so now we use this trick that I told you about. We just write this part of the name, so dice and then the number that was rolled. So dice plus, so actually dice, right? Because this variable here, which has the number from 1 to 6, which the dice rolls. And now we just need to add the final .png plus .png. And that's it. So it's now time to test this again. So let's reload this and then roll the dice. And now this is not really working. So let's check out the console. And the error that we get is that the dice is not defined in line 20. So let's check that one out. And yes, indeed. So here we use the dice, but it's not defined because it's only defined down here. But it's not a problem because these lines here in the beginning, they were only to show you some things which I don't want anymore here anyway, because we are just going to use these inside of a function or even of another function. So these one were just to test some things. So I will just cut them here and put them down here in case I need them later. And I will need them, of course. So the only thing that matters for our application here really is these variables, then hide the dice, and then our event listener function here. So let me close this, reload, and now it's going to work. Alright, so 5, 6, 6, 3, and so on. So now this works. Really cool, right? So our game is starting to look nice, right? What I want to do now is to actually set these values here to 0. And I'm not going to do that in the HTML code, but right in the JavaScript. So let's do that. So we come here to our HTML to see how these are called, and these are the score 0, current 0, and score 1 and current 1 IDs. So these are IDs. Now we could of course use the document.querySelector just fine, such as we did before, but I want to show you another method now, which is the document.getElementById instead of querySelector. So this only works for IDs, but is faster than querySelector. So sometimes when we have IDs, instead of just using querySelector all the time, we use getElementById for IDs. So let's do that. So document.getElementById. And now we don't use the CSS style, so we don't use the hash symbol such as we did if we would use the query selector, but all we do is to put the name in here. So it's score 0 and then text content, as you already know, right? And set it to the string of 0. And I will now duplicate this line, and we'll do the same for the score 1. And I will actually duplicate it 2 more times. So we do it for the current 0, and then current 1. Okay, and with this we set all the 4 values to 0. So again, we could have used query selector here, but we used the getElementById method, which is a bit faster. And also because I want to show you that query selector is not the only way that we have to select elements. So let's now check this out. And indeed, everything is now set to 0. Alright, are you excited to continue with this? Then come with me right to the next lecture. In this lecture, we will continue to build our project and developing the game logic. So in this lecture, you will find out what the ternary operator is, and you will learn how to add, remove, and toggle HTML classes. Alright, so we are still in the event listener, which controls what happens when the user clicks on the roll button here, right? And so we already calculate our random dice number, and we also already display the corresponding dice number in the middle of our user interface. So now we need to continue developing our game logic here according to the number that the user rolls. So if the user rolls a number different from 1, then the score gets added to his round score and he can continue to play, and otherwise if he rolls a 1, then it's the next player's turn. So let's do that using an if statement, right? So if the dice is greater than 1, then add the score. So add score, and if not, then it's the next player. And I really like to do it this way. So write our if statement first and then add a comment telling what I'm going to do. So here I said that the dice number should be greater than 1, but I could also have said simply that the dice should be different from 1. And since we already know this one here, I'm going to show you the difference operator, which is simply this exclamation point and then equal equal. And this is the one that doesn't do type coercion. So remember, the equality operator, we have the triple equal, and this one doesn't do type coercion, while the double equal does type coercion, and it's the same for the different operator. So we have this one which performs type coercion, while this one with the extra equal, which does not perform type coercion. So we always want to use this one. Alright, so let's add the dice result to our round score. So we have round score, and now I'm gonna use the operator that I showed you in the introductory lectures, which is the plus equal operator. And now I can simply add the dice. Right? So once again, this would be the same as writing round score equal the current round score number plus the dice. But this here is much simpler and cleaner, so that's how we do it, right? And again, we can use the round score variable right here in this function because it was defined here in the global scope, and therefore, due to the scope chain, we have access to that variable in here. So we updated our internal variable value, but we also want to display it in the user interface, right? And we actually already did that down here, which I deleted, but we can get it back from here, right? Because you already know how to do this. So remember this trick here that works with the active player. So if the active player is the number 0, then the current 0 element will get the text content. And if it's player 1, then the current 1 element gets the content. And the content that we want is, of course, the round score, right? So each time after the player rolls the dice, we want to first update the round score and then display the round score in our user interface. And that happens in this element with this class. Okay, so let's quickly see this in action. So I'm refreshing and I'll roll the dice. So this is adding here because I have the active player as 1, right? So let's quickly change that, because the default will always be that the first player begins, so player 0. So refreshing this, now roll the dice. So 5 plus 4 is 9, plus 2 is 11, plus 6 is 17, so yeah, this is working. So let's see if we can catch a 1. So 34, 36. Alright, so here's the 1. So this time we didn't add the 1 here. Now what we want to happen is that now is the turn of player 2, right? So let's implement that. And we're going to do that here. So if the player does something that is equal to 1's, then we want the next player. So the first thing that makes sense to do now is to change this variable here, right? So active player will change from 0 to 1. And how do we do that? So if it's 0, then we want 1, and if it's 1, we want 0. So it makes sense to use an if statement here, right? Actually, we can use something else, which is still an if, but it's an easier way to write it. And that's called the ternary operator. And it simply works like this. So the active player is what we want to test. So we still have our test condition here. So if it's 0, then active player should be 1. Else active player should be 0. Okay? So this is the exact same thing as writing if active player equals 0, then active player 1, else active player 0. Okay, but this is much cleaner and much simpler, right? So for a very simple if statement, such as this one, I like to use the ternary operator instead. Okay, so let's see what happens then with the score. So we need to catch a 1 here. Alright, so now we have a 1, and now we should continue on this side, right? Because now it's player 2. Okay, so now we have a score here. But the thing is that we didn't restart at 0, right? We still continued with the 17, so 17 plus 6 makes 23. But we of course want to start this player as 0 as well, right? So there's something else that we need to do here, which is to set the round score back to 0. Okay, so when one player rolls a 1, then the other player becomes the active player and the round score is reset to 0. And now it should work, right? So and now it should go to the other player. Alright, so 3 and 1 again. So now it's this player's turn again. And alright, we start from 0 again. and the game keeps working. Now there's still a couple of things that we need to do here, right? Because as we know from the rules, as soon as the player rolls a 1, he loses this score. So it should be set to 0. So it should not be set only to 0 here, but also in the user interface. So you need to do a couple of things here. So let's select these. So current 1 and current 0. And once again, we're going to use the getElementID method for that. So document.getElementById, and now it's current 0.textContent. We want that to be set to 0. And the same thing, of course, for the number 1. Okay, and another thing that we should also do is to make it visible in the user interface who is the active player. So what I mean is this bold text here and this red dot, and also this gray background. So let me first show you in the HTML how that is actually achieved. So in here we have this active class on the player 0 panel that we do not have in the player 1 panel, right? So it's this class here that makes all the difference. Let me remove it from here to show you the difference. Alright, and now this is not active. So right now player 1 looks exactly the same like player 2, right? So what we have to do is to, as soon as the player changes, we have to remove the active class from the player 0 panel and add it to the player 1 panel. And this is one of the really cool things that we can do in JavaScript to style our applications, is removing and adding classes like this, like we're going to do now. So we need to, as you already know by now, start by selecting the element that we want. So document.querySelector, because it's now a class. So this one was called player 0 panel. And then we need a class list. And in here we have a couple of methods to add, remove, and toggle classes. So let me first show you the remove one. Remove. And now all we have to do is to pass in the name of the class that we want to remove. And it's as simple as that. So now the active class will very simply get removed. And just before reloading the page, let's then add a class to the other panel. So query selector and player 1 panel. And once again, we need to use class list, and then we can simply say add. And once again, we need to specify the class that we want to add. So let's now see this. Alright, so I'm waiting for the 1. Alright, so here it is. So the active class was removed from here and added to here. And like this, we can now visibly see here that player 2 is now active. And the other change that we did before is also reflected, because this is now back to 0. Okay? But now you saw that I rolled a 1 before. I actually clicked a bit too fast here, but the player didn't change. And of course it didn't, because we didn't tell the code to do so. So let's go back. And one way that we could do this would be to say, alright, if the active player is 0,